I think most likely, this is just about probability, there are many simulations. These simulations are, you might as well call them reality, or you could call them multiverse.
Quantum mechanics it ends up being a optimization technique for rendering of the physical world from the information that lives below.
Why are some of the smartest minds convinced that our reality is a simulated construct? And if they're right, what does that mean for consciousness? As we zoom out from our daily lives, the sheer scale of the universe becomes incomprehensible. The observable universe stretches a mind-boggling 93 billion light-years in diameter, filled with countless celestial bodies and structures we're only beginning to understand.
I'm going to turn all the galaxies in the universe into pieces of cereal and pour them on my head in this swimming pool. And the question is, how high will they all reach?
Yet, in the midst of this vast cosmic stage, the Earth occupies a position of remarkable precision, especially when it comes to its relationship with the Sun and the Moon. Our planet orbits the Sun at just the right distance, often referred to as the Goldilocks zone, for liquid water to exist on its surface. This distance is crucial for maintaining a temperature range that supports complex life. Meanwhile, the Moon, though much smaller than the Earth, is placed close enough to exert a stabilizing influence on our planet's axial tilt and generate ocean tides. These tides play a significant role in distributing nutrients, shaping coastal ecosystems, and influencing weather patterns. Without the Moon's steadying effect on Earth's tilt, our climate would be far more volatile and less hospitable to life. Even as we marvel at the vastness of the universe, the Sun and the Moon remain arranged with astonishing precision in relation to Earth, an elegant testament to how finely tuned our nook of the cosmos truly is. According to the anthropic principle, the universe's fundamental constants, such as the gravitational constant and the speed of light, appear calibrated in just the right way for life to emerge. These constants shape everything from the behavior of subatomic particles to the stability of planetary orbits, illustrating how even slight variations could dramatically alter our planet's habitability.
Were to change in, say, the 9th decimal place, the whole universe would be unstable and wouldn't work. So the only way that this universe has stayed here for all these billions of years is because these set of constants are balanced perfectly. They're tuned to each other.
As we peer deeper into the fabric of reality, both at the cosmic and quantum scales, we're discovering that the universe doesn't quite behave the way we thought it did. Take quantum mechanics, for instance. At the subatomic level, particles can exist in multiple states simultaneously, teleport across space, and even influence each other instantaneously across vast distances. It's as if two perfectly choreographed dancers on opposite sides of the world are connected by an invisible thread. The instant one dancer raises an arm, the other follows in flawless sync. Then we have the double slit experiment, which tests how light and subatomic particles can exhibit both wave-like and particle-like properties. When light or these particles pass through two narrow slits, they create an interference pattern of bright and dark bands. However, when someone observes which slit they go through, that wave-like pattern disappears, and they behave more like individual objects. This strange phenomenon shows that merely observing something in the quantum scale can alter its behavior. A simple way to imagine this is to picture a single person facing two side-by-side doors. They somehow go through both doors at the same time. But the moment we try to see exactly which door they used, we find them coming out of only one. This striking mismatch between our observations and the bizarre underpinnings of quantum physics has prompted scientists and philosophers alike to propose bold new perspectives on the true nature of reality. One of them is the simulation hypothesis, popularized by philosopher Nick Bostrom. Imagine a future civilization so advanced that they can run incredibly detailed ancestor simulations of their own evolutionary history, or even create entire simulated universes. Nick Bostrom's argument says at least one of these three things must be true. 1. Almost no civilization ever gets that advanced, meaning we'd go extinct before reaching such technology. 2. Even if they do get that advanced, they don't bother running ancestor simulations. Maybe they have no interest, or there's a universal reason to avoid them. 3. We're already inside a simulation right now, and everything we experience is just part of that program. Bostrom suggests treating all three possibilities as roughly equal. That means we're left with a big question mark about our place in the cosmos, and whether our entire reality might be a clever piece of code. It sounds like a really good movie premise.
You ever have that feeling where you're not sure if you're awake or still dreaming?
All the time. It's called mescaline.
But when you consider the rapid advancements we're making in fields like virtual reality and artificial intelligence, it seems plausible. We're already creating incredibly detailed virtual worlds and AI systems that can learn and adapt. Some physicists are beginning to see the universe as a vast computational system, where information and computational processes are not just tools for understanding reality, but may actually form its foundation. Max Tegmark, a physicist and cosmologist, has proposed that the universe operates as a mathematical structure, suggesting that everything we perceive, from particles to galaxies, follows precise mathematical rules, akin to a computational framework.
And the uncanny feeling I've been getting, the more physics I've done over the years, is that we keep discovering that our reality is more and more like this kind of computer game world where we look at things where we were pretty convinced that there was more to it than just the mathematical properties. And then eventually all the other stuff sort of melted away. Like we look at the Jupiter and we realize we can describe the whole thing seems to be made of electrons and quarks in some certain arrangement. So far, we have found no phenomena at all in science where we're convinced that they cannot ultimately be described with the tools of science, physics and math. And some people would disagree and say maybe consciousness is different.
Similarly, Rizvan Virk, an MIT-trained computer scientist and video game pioneer, has drawn parallels between the probabilistic nature of quantum mechanics and the on-demand algorithms in modern video games. Just as particles don't settle in a definite state until observed, game engines often render environments only when the player is near, highlighting a possible parallel between how reality updates upon observation and how virtual worlds are generated based on a user's position.
It starts to look less like the physical world exists and more like it's a bunch of information that gets rendered as we observe the world or as groups of people observe the world.
And if we're in a simulation, how would we know that the reality running our simulation isn't itself a simulation? Before we go too far down the rabbit hole of nested realities, we have to remember that every single layer, real or simulated, is filtered through our own consciousness. And consciousness is one very important variable that isn't clarified in Bostrom's theory. How does the mind, the ultimate lens, interpret and shape what we experience? We often take our senses for granted, assuming they provide an accurate picture of the world around us. For example, humans can only see less than 1% of the electromagnetic spectrum. Specifically, the wavelengths between approximately 400 and 700 nanometers, known as visible light. Let's do a quick thought experiment. Close your eyes and picture an apple. Imagine the waxy glint on its smooth red skin and the tiny stem perched at the top. Where does this picture actually exist? Is the apple in your mind any less real than the one you might hold in your hand? If our brains can generate such vivid images without external input, then perhaps they're not merely observing a world out there, but actively constructing the reality we experience. Neuroscientists and cognitive psychologists have uncovered that what you see, hear, and feel isn't some unfiltered feed of the world. It's more like a high-tech simulation, custom-built by our brain. Sure, it's based on sensory input from the outside world, but it's deeply shaped by our expectations, memories, and beliefs. In other words, your brain is more of a storyteller than a camera, piecing together a narrative of reality that makes sense to you.
Or to describe how the brain works, it goes something like this. Your brain, my brain, everybody's brain, is trapped in its own dark, silent box called your skull. And the brain has no knowledge of what is going on around it in the world or in the body, right? Because it's in this skull. And it's receiving sensory signals from the sensory surfaces of your body. These signals are the outcomes of some changes in the world or in the body. But the brain doesn't know what the changes are. It's receiving the outcomes. And that is what philosophers and scientists call, you start with an outcome and you have to guess at the cause. For example, if you hear a loud bang, it could be a car backfiring, a door slamming, it could be a gunshot. Your brain doesn't know what the causes are, it only knows the effect. And so it has to guess. And the guess is important, right? Because you would do different things if it's a gunshot versus if it's a windy day that slammed a door. And luckily, it has one other source of information, and that is your past experience.
The ease with which our perceptions can be manipulated is remarkable. Reality isn't just what we perceive. Let's test this. At first glance, a photo of a familiar face seems perfectly normal, until it's flipped upside down. What do you notice? The eyes and mouth have been inverted, creating a bizarre distortion. When upside down, your brain struggles to detect these changes because it processes faces as a whole, rather than focusing on individual features. Here are 5 cards. Go ahead and pick one in your mind. Really focus on it. Now watch closely as I take your card out. Did you see what happened? On the top are the original 6 cards, and on the bottom are completely different cards. Reality is not always exactly as we perceive it. We often assume our senses and perceptions reveal the whole truth, but subtle manipulations and hidden details can shift the picture dramatically. Our perceptions can be influenced by expectation, focus, and context. These are examples of how our brains prioritize efficiency over accuracy, overriding the raw physical reality in favor of what it expects to see. Virtual reality experiments have pushed this concept even further. Researchers have induced out-of-body experiences and altered people's perceptions of their own bodies using nothing more than clever visual and tactile stimuli. These experiments demonstrate how malleable our sense of self and reality truly is. Some philosophers and scientists argue that our entire experience of physical reality is a projection of consciousness. This idea echoes ancient concepts like the Vedic notion of Maya, which suggests that the material world is an illusion. The idea that our reality might be an illusion isn't new. Plato's allegory of the cave, dating back to ancient Greece, suggests that what we perceive as reality might be nothing more than shadows on a cave wall. These ancient philosophies are the foundation for modern simulation theory. Cognitive scientist Donald Hoffman proposed that our perceptions have evolved not to show us the truth, but to give us a useful interface with the world. Just as the icons on your computer desktop aren't the actual programs they represent, our perceptions might be simplified representations of a deeper reality we can't directly access.
In fact, we're constructing everything that we see. We don't construct the whole world at once. We construct what we need in the moment.
But when you really face the fact that you're going to die, and then when I start to look at it from this point of view, that, well, this thing was an interface to begin with. So what I'm really going to be doing, just taking off a headset. It was a data structure, and the data structure is gone. So all of the wars, the fighting, and the reputations, and all this stuff, where it's just a headset.
Have you ever experienced a moment of déjà vu so vivid it felt like a glitch in reality? Some researchers suggest that déjà vu could be like a system reboot, giving us a brief peek behind the scenes of our world. Imagine a template-level reality that exists between the physical and non-physical. This level could act as a blueprint for creating our physical world. When we dream or have out-of-body experiences, we might be tapping into this template, defining experiences that eventually shape our reality. These experiences crystallize into real events, leading to the familiar sensation when we encounter them again in our conscious reality. As an example, imagine your life as playing a role-playing game filled with countless unique experiences and choices. Behind the scenes of this game lies a complex engine that generates the world, its landscapes, characters, and events based on certain rules and patterns, a kind of template-level reality that provides a structured framework for our environment. When you experience déjà vu, it's like encountering a familiar scene in the game due to the engine recycling assets or patterns, a glitch that gives you an eerie sense of familiarity. The sensation doesn't explain everything, but it serves as a curious artifact, much like a game glitch that suggests our reality might be crafted by an intricate system, weaving together moments that sometimes feel both new and oddly familiar. People who've had near-death experiences often report observing reality from a detached perspective, as if they're floating outside of their physical form avatar. Even more intriguing are the life reviews that some people have. It's as if their entire existence was recorded, much like how we might review footage.
We survived. Somewhere in their fifth dimension, they saved us.
Who the hell is they? And just why they want to help us, huh?
I don't know, but they constructed this three-dimensional space inside their five-dimensional reality to allow you to understand.
These experiences hint at a consciousness that exists beyond our physical bodies, perhaps interacting with the simulation from a higher level. But the signs also exist in nature. Consider the spiral arrangement of sunflower seeds, or the spiraling shells of a nautilus. Both follow the Fibonacci sequence and the golden ratio, creating aesthetically pleasing and efficient natural designs. Look at pine cones and pineapples, where the arrangement of scales or segments also reflects Fibonacci numbers. The branching patterns of trees and the formation of snowflakes often exhibit symmetry and proportions that mirror prime numbers and the golden ratio. Across the universe, from the spiral arms of galaxies to the way crystals spontaneously form perfect structures, everything seems to pulse with pattern, an intricate symmetry that doesn't feel like random chaos. What if these patterns are actually encoded for the very fabric of reality? And what if, beyond physical reality, this hidden code is also shaping our consciousness? This idea mirrors what people sometimes experience during deep meditation or when under the gaze of psychedelics: visions of swirling geometries, complex grids, and fractals.
The thing to notice about fractals is the way they do their magic is they are nested, the same set of perturbations or the same set of value changes are nested again and again into each other on many, many levels. And so that what is implied if we say that there's a fractal description of the rainforest, and there's a fractal description of river systems, and there's a fractal description of the coastline of the continents, what that implies is that there therefore must be a fractal in which all of those fractals are somehow subsets, and that the planet itself is some kind of fractal object. These mathematical objects look like hallucinations. Do hallucinations look like these mathematical objects because the nervous system is organized this way, and we're somehow getting an organizational insight into how either the physical matter is arranged or how the data is being handled. And this may be the key. If language turns out to be fractal, well, then this is the key to understanding learning, memory. It sort of explains how we can be in the world.
If we really are living in some high-tech sim, that doesn't necessarily cheapen our experience. If your joys, heartbreaks, and eureka moments are all coded, does that make them any less real to you? Across the globe, ancient cultures and mystical traditions have been saying for centuries that our everyday reality is a kind of dream or illusion. We might all be these eternal consciousnesses who are plugged into the matrix on purpose, thirsting for challenge and experience. That doesn't strip life of meaning. It could mean every choice we make carries more weight, because there's a hidden grandeur behind it all. Maybe our real selves exist beyond the screen, logging in from some higher plane, and everything we do here is part of a grand storyline that's unfolding, whether we see it or not. Please like and subscribe if you enjoyed this content. Could the simulation actually be a hologram? Check out this next video to see how.